name is Cooper Stone, and this is my Physics 2212 Lab 1 about charge tapes. The goal of this lab was to experimentally place two pieces of charge tape close to one another and observe their interactions, while also doing an analysis of the distance between them and comparing that to other known factors such as mass and surface area to determine the charges, and then using that same data, create a computational model in GlowScript that models the two pieces of tape as point charges interacting with one another and reaffirming the calculations that were previously made. So some essential concepts include the force of gravity on Earth's surface. An acceleration due to gravity is 9.8 meters per second, and the force of gravity on an object is that object's mass times that acceleration. And finally, Newton's second law, which says that the net force on an object is equal to the object's change in momentum over change in time. Additionally, the electric field equation and electric force will also be used. The electric field at a spot in that field is equal to Coulomb's constant multiplied by the charge creating the field's charge divided by the distance between the point charge and the observation location squared. And then to find the force of that point charge on another charge, simply multiply the electric field by that secondary charge. Some assumptions include that the two pieces of tape have equal magnitude of charge and that they function as point charges, which helps with computational modeling, but in reality is not necessarily what it actually acts as. Experimental methods involve making two U-tapes by placing and quickly removing pieces of tape from one another to cause an exchange of electrons. And then computational involve making a script to model the pieces of tape while also coming up with the necessary calculations. Here you can see a basic diagram of the system, with the top tape being repelled by the bottom tape while also pulled down by force of gravity, equal in magnitude but opposite direction, which caused the top piece of tape to float. And the bottom piece of tape also had a zero net force, which is why it was not moving. Some physical characteristics of the tape includes length and width multiplied to find the surface area, and then the tape mass was estimated by multiplying the length of the tape by 1 gram per meter. The distance between the tapes was measured when the top tape floated, and the gravitational force on the tape was found by multiplying its mass times acceleration due to gravity, and this was set equal to the electric force because the two together contribute to a zero net force, so they have the same magnitude, and that calculation can be seen below. And then the area of an atom was found by squaring the length of an atom, and the number of atoms on the tape was estimated by dividing the tape's area by the area of an atom. And then the charge was found using the equation below, or rearranging the electric force equation. And the number of electrons lost was found by dividing the tape's charge by the charge of an electron, and the electron-atom ratio was found by dividing that deficit by the total number of atoms in the tape. Here you can see my GlowScript code, where I set the constants and then perform the necessary calculations, and then finally model the two pieces of tape as point charges that interact with one another. And you can see the results of that, where they're separated, and the top tape has two forces, the electric force pushing upwards and the gravitational force pulling down, resulting in zero net force. So clearly the tape had a positive charge of about 1.348 times 10 negative 8 coulombs, and it was determined to be a positive charge because it was attracted to negatively charged things such as plastic pen, my skin, and stuff such as that. And because the tapes repelled, they had to have the same sign of charge, so they were both positively charged. It was assumed that the electric force was equal to gravitational force because the lower tape caused the top one to float, meaning there was no change in momentum or no net force. And some possible sources of error include inaccurate separation distance when trying to make it float, estimating number of atoms, weight, things such as that, and then hand contact that could have caused a loss of charge and changed the results. And building off that, one question is, what if electrons had a positive charge and protons had a negative charge? The interaction, although the nature of the two particles would change, the interaction would remain the same, because even if the electrons that they lost were positively charged, giving them a negative charge, they would still both be negatively charged or repel one another, so this would not change the overall results of the lab. And it is important to handle the charged tapes as little as possible, because when surfaces come into contact with one another, an exchange of electrons occurs. So that means anytime the piece of tape touches a hand, a surface, something like that, it tries to regain those electrons it lost and reduce that positive charge, which can alter the results of the lab.